Hello and welcome to another one of D's ADD videos. Today we're going to look at a basic example of the second derivative test for relative extrema. So quick recap, what we do, steps are as follows. We first take the first derivative in order to find our critical points. Then we take the second derivative, plug in our critical points, and evaluate. The conditions are opposite what common sense would dictate. You would think the word greater, positive, greater than 0 would be a max, but it's actually a min. And you would think negative, less than would imply a min, but it's actually a max. So opposite what common sense would dictate. So let's look at this example. First step, again, was to take the first derivative, so let's do that. Just use the power rule, bring the 3 down, subtract 1 from the exponent, same thing for that one. Because they're added, subtracted, you can do each one individually, and the derivative of a constant is 0. If I set that equal to 0, at that point, I can factor out an x, and a 3 actually, and be left with an x minus 4. If I set those individually equal to 0, I get 3x equals 0, and x minus 4 equals 0. These are my critical numbers that I'm finding. And if I add 4 on both sides, I get that. So these are my critical numbers, or points. Normally you would do the first derivative test, plug in that number to the first derivative on either side, and increasing, decreasing would be max, then decreasing, then increasing would be a min. But in this case we're going to take the second derivative and plug these critical points into that second derivative. So the second derivative tells us it's 6x minus 12. Now if I plug in 4, you get 6 times 4 minus 12. And that's going to give me a 24 minus 12, which is 12, which is greater than 0. Now at this point, now that I know I'm greater than 0, I can evaluate it to look at the opposite what common sense would dictate. Greater than 0 is a relative min. So therefore you can say 4 comma f of 4, whatever the function value of 4 is a relative min. So if you were to plug in 4 into your equation, you should get a negative 31 as an answer. So whenever you plug in 0 into the second derivative, you get negative 12, which is less than 0. Therefore, opposite common sense, less than would imply min, so it has to be a relative max. Now in this case, 0 is pretty easy to plug in, and you'll get a 1. If you plug in a 0 here, 0 there, you get 1. Alright, so that's using the second derivative to tell us extrema, not concavity or points of inflection. Alright, so hopefully I've cleared up the basic concept. Practice, practice, practice. Check out the intermediate and advanced examples videos. Thank you and have a nice day.